That's why the U.S. and China called artificial intelligence a catalyst capillary. You know what I'm trying to say. Anyway, welcome to Moral High Ground. I just get carried away, just want to get into whatever I'm talking about, and don't know what the hell I'm talking about half the time. But telling you right now, we're about to get into some deep stuff. And so I watched like, I don't know how many seconds or minutes, and I said, okay, well, I might as well just review this while I'm watching it and do it, for the podcast here. So here's where I'm going. We're just gonna get into it, man. But I want to tell you all, if you like this whole thing I do, please subscribe, start sharing, start finding people who's got the similar mind as you to find me interesting, and yeah, let's just get into it.
In the universe, there exists something more complex than a black hole, and it's right inside your head. The human brain is not just the birthplace of our dreams, but also a cosmically intricate apparatus that has puzzled generations of scientists. But what if I told you that now we're not just trying to understand it, but also to recreate it? We're talking about cloning, but in the...
So, pause it. What he just said is something I said a while back. And it's just something I believe. I believe that energy can be harnessed in space. And I don't know why, but there was something when I was like younger, and I was really into the X-Files, and this is going to make me sound way nerdier than usual, but I used to have this big poster of Mulder and Scully in my room, and, and then I would go to the library and read books on like alien abductions, and I had an alien autopsy movie I watched. It was a big thing back in the 90s, and then there was this book about all these people that got abducted, and they talked about a couple of them you read, and then later on, which was cool, was there was this show, and there was like the people that was in the book were explaining this on camera, and they had a whole reenactment of it with these alien creatures, and I was like, oh man, that's why I read this book. But yeah, but they were talking about the aliens being able to mind control the individuals, the cars, and everything. And so what makes me think about humans' emotions and mind and thoughts and energy being brought into space is because it's all about the same creation. If we got negative stuff going on, I believe negative things happen to the world. Hence where we're at right now. There's a lot of negative stuff happening in the world, a lot more than usual. And because of this, there's a lack of hope in people. But there is people who are bringing hope, which is another episode we'll be talking about later on this week. And it's pretty cool. And it's something I'm a little bit behind on, but that's because I'm not in linear time. I'm in Shelby time, or SOK time. So, with that being said, we're going to get back to this, so... Oh, crap, I don't know what I just did.
Digital realm. And no, this isn't the plot of a sci-fi story or a new blockbuster. This is the reality of modern technology, a world where biology and programming become nearly indistinguishable. In this video, get ready to dive into the thrilling world of artificial intelligence and neural networks. From the moments of inception and the early steps of neural networks to their monumental breakthroughs in the 21st century, discover the geniuses behind these discoveries and the challenges they faced. Are you ready to embark on a scientific adventure? Let's get started.
Okay. So the whole title of this thing is retarded and doesn't make sense to what I thought it was. Why America and China call artificial intelligence, blah, 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 blah. And then I was thinking about this alien one I was going to do. I guess I forgot about that. I picked the wrong one. I have no idea. Anyway, neural networks. Let's get into it. So, I've seen a 60 Minutes episode with a neural network, and I was going to pick this episode because it was very interesting to me, because they found a way to make a robot. Okay, so first off, they hook things up to a person's brain, not neural network, certain parts of the brain that can feel touch and be able to do things, and they connect this robot arm to it. So they connect the robot arm to your brain, and when you shake its hand, the person is actually able to feel the robot's hand being touched, and so forth. It's on this episode of 60 Minutes. I seen yesterday or the day before, and I thought it was very interesting. I'm thinking, okay, that's cool, but does it truly help? And would they put it in someone that's got rage issues or whatever? So, the concept is amazing, but at the same time terrifying, horribly terrifying. We're talking about putting a robot and connecting it to someone's human brain and having that person be able to do things that normal people don't do. Now, the reason why it's terrifying, of course, is because of that. We don't know. There's so many doubts, there's so many worries, there's so many thoughts. But the positive is the person that can no longer feel things with their own physical body is now able to feel something using robotics and technology thanks to neural network. And the more advanced make it more real for that person and give them their hope and life back, especially if they're disabled, quadriplegic or whatever, and now they're able to use their limbs, or these robotic artificial limbs. And so it's a amazing thing and a way better form of science to help someone that needs the help. But how far would they go with that? Are they using that as a form to analyze someone's mind and be able to put that sensation to be able to feel into a robot? Well, it's already been done in Japan. There's a robot that can feel when people touch it. And it was the first thing that got me understanding the whole thing about AI robotics and stuff, where this guy decided to make a female robot and it could feel you touching his hand and so many other things. So I believe the opportunities for this research is limitless. It's limitless. I say things so weird, but it's limitless. And so, yeah. Anyway.
Let's move back to the times when computers were the size of a room and the cloud was just, well, a cloud in the sky. At this moment, two people entered the arena, Warren McCulloch and Walter Pitts. It's not the name of a 1940s rock band. It's a duo of geniuses who set out to unravel the mysteries of the human brain. McCulloch, with his biological insight, and Pitts, with his mathematically hungry mind, formed a dynamic duo. Think of them as the Batman and Robin of neuroresearch, but without the capes and Batmobiles. So in 1943, they presented a mathematical model of a neuron. With their model, it became clear that the brain could be represented as a network of interactions. The neuron receives a series of input signals, performs a mathematical operation on these signals, and if the result exceeds a certain threshold, the neuron activates and transmits the signal forward. Thus, each neuron was represented as a simple binary computational unit, and its state could be described as either on or off, based.
So this is pretty interesting, that the whole concept of this neural networking science is not just based off of brain, is based off of numbers. That's pretty cool.
On this model, it was suggested that complex cognitive functions could be achieved by combining these simple elements into more intricate structures. This was the first attempt to apply a logical and mathematical approach to studying the brain. After McCulloch and Pitts introduced their idea to the world, the scientific community was thrilled. The concept of modeling neurons in a mathematical form seemed so enticing that even internet cats would lose their popularity before it. But as it often happens, there's a huge gap between an idea and its realization. The initial neural network models were strangely enough oddly cute. If our brains function like these early models, we might still be trying to figure out how to start a fire or invent the wheel. In the night.
So, what we're getting at is that the science isn't just based off of brain tissue and matters based off of mathematical equations. It somehow can link these two together and work perfectly as, I don't know how to say this, an artificial brain is what I'm about to say, because they're talking about how the brain comes together and makes this whole neural network. And the neural network isn't just the only thing. There's a cybernetic network type of thing going on too. So, well, pretty deep science.
1950s and 1960s, thanks to scientists like Frank Rosenblatt, the representation of neurons as mathematical equations started gaining momentum. Rosenblatt created the perceptron, and it's not a new type of dinosaur. It's one of the first learning algorithms for neural networks. It was capable of classifying input data based on a simple hierarchy of input and output nodes, applying iterative learning to correct its mistakes. The perceptron could adapt to new information. Imagine it like a thermostat in your home. It senses the temperature, makes decisions about whether to turn the heating on or off, and adjusts its actions based on feedback received to maintain the desired comfortable climate. This self-learning ability made it extremely innovative for its time, opening the door for future research and developments in machine learning. However,
So that's pretty cool. It's learning on its own in a way that benefits people. This is a lot of stuff. There's a clip they just showed too with this robot. It's fake. It's fake as all hell. But you see it in a lot of YouTube videos where this guy's in a white robot costume and he's moving around. And because they're talking about AI and artificial robots and I guess you say the love dolls or whatever you want to call them, the sex dolls or whatever, then automatically you assume that that thing is real too, and it's totally not. I just want to make that clear. So when you see this like wide face robot and it's white and white and black robot and it's big with big chest and stuff, there's a dude inside there, and he's an actor. It's just acting, and because it's on every stock footage you can get for every editing system, just so you know.
like any first version of something, the perceptron had its limitations. It could handle only specific tasks, akin to trying to install the latest app on the first iPhone. Despite this, these early studies paved the way for the creation of neural networks that today can, for the most part, spend our time watching videos online. Yet this path was filled with both remarkable discoveries and failures. The 1970s brought the artificial intelligence winter. Expectations for neural networks were as high as a lunar expedition, but unfortunately not all problems were successfully solved. One of the reasons was a public statement made by Marvin Minsky and Seymour Papert in their book Perceptrons, where they pointed out the limited capabilities of simple neural networks. This statement influenced the perception of artificial intelligence in the academic community and led to reduced state and private funding. Many research programs were shut down, and budding AI experts began to look for opportunities in other scientific fields.
So I'll have to pause it there and just think about that. The neural network was a thing that was booming, and this was in the late 70s and stuff that it was booming, and then it got shut down. How many other forms of science has been shut down and stopped and held back from us to stop us from being limitless and understanding our true potentials as super beings? I'm not saying that we're superheroes or whatever, but the most ultimate of beings on Earth, or should I say a living being. You know, I'm not saying that there isn't a God, or that there isn't gods, or anything more powerful than us, but we're probably being held back in so many forms of science and medical field knowledge and things, and I believe this to be true because I know a story of a doctor named Terman, and he created something called Terman's toxins. Somewhere between the 30s and 50s, he created the Terman's toxins, and at the early signs back then of an illness that was just becoming brand new that we know today as cancer. And he had a patient that died, and there was another guy in upstate New York who had a patient that was similar things going on with the patient before that patient died, or was supposed to die, like Terman's patient did. Instead, he was able to revive that patient, and the person was fine and never had that illness again. So Terman went to this guy, got his research, took it together with his, and found a way to create these Terman's toxins based off of mushrooms and things, and was able to cure cancer, and actually did it with another patient that had a form of cancer. Now the government shut his whole process down and created what they felt was the best way to treat cancer, through radiation or treatment. And this is what we use today. And then there was some story about his daughter, years later after he died, found his work, and she was in the medical field as well, and realized that her father's work was very good at curing cancer. And it was hidden from us, and it still is. A lot of people are not aware of this, and I'm not just making up the story. You know, I go on these big research of things, and it doesn't take me long because I'm like a natural at it. You know, there's certain things you can find out real quick without having to use the interweb, you know, but with the interweb it makes it a lot easier to find things. And you can just research through books and things, and you'll find these things, and I'm not making it up. So somewhere you can find terminus toxins, you'll know what I'm talking about. But that was a medical field science that was hidden from us, as well as what's going on right now with so many other things that we got. Like right now we have the internet, but the internet's been around longer than before it was created in the 70s and 90s. It's been longer than that. A lot of things have. And so we have to take this into consideration, that they hide things from us so they can use it to their advantage. And when they find it's useless because some form of science or creationist came about, they start using it and give us the old stuff. So pretty much the governments give us hand-me-downs of their science and their medical research. And this is the truth. And if you don't believe it, just go out there and see. There's lots of stories. There's lots of things. There's even one, the more common one people know about, that I know, is the one, that car that ran on water. And people talk about it all the time. You know, there's friends I know that work on cars and places, and they always say, well, have you ever heard about the car that ran on water? You know, and it's like, oh no, that's fake, and oh, it's real. So it's like a myth. But there's actual clips of this car that ran on water. You know, so the truth is out there, like they say in the X-Files. And so it's out there. Just look for it.
This era was marked by a series of unsuccessful projects that did not justify the funds invested in them. However, the 1980s brought about a retro renaissance. Neural networks decided it was time to return to the big stage. And here it was. The backpropagation method by scientists like Geoffrey Hinton, David Rumelhart, and Ronald Williams became what a new hit track is. Everyone was talking about it. This method provided an efficient way to train multi-layer networks, which had seemed almost impossible before. With it, networks could go through the process, making a prediction, calculating the error, and then adapting their task to minimize this error. At its core was a concept of a simple yet brilliant idea. When a neural network makes a prediction, and that prediction turns out to be incorrect, you can backpropagate the error back through the network to understand how each neuron contributed to the error. Knowing exactly how each neuron made a mistake, you could slightly adjust its behavior so that it behaves more accurately the next time. With these new algorithms up their sleeve, neural networks reached a new level. So after neural networks lived through their youth in the 1970s, they opened the door a little bit in the 1980s, and the 1990s became a real boom for them. And here's what happened. A great breakthrough in convolutional neural networks by scientist Yann LeCun. LeCun demonstrated the advantage of his algorithm by training his LINET5 network to recognize handwritten digits in the MNIST database. This success propelled further research in the field of deep learning and convolutional networks, making them the gold standard in computer vision tasks ever since. Next, recurrent neural networks took the stage. They represent a special class of artificial neural networks specifically designed for processing sequences. The main difference of this algorithm from other types of neural networks is that they have memory, preserving information about previous steps in the sequence.
Okay, so pausing it. So right there, if you don't know what they're talking about when they're saying neural networks and what they're talking about here, of the whole memory and all that, they're talking about artificial intelligence, they're talking about AI, they're talking about your replicas, they're talking about these love doll thingies that keep trying to keep real doll, love doll, whatever the hell they are. And this is what they got. This is why they seem human. It's because they're able to process memories through a neural network. And with a neural network, and so many words apart that they're not getting at, that I'm wanting them to get at is the coding part. This is all coding. You know, you're coding things again, you put it together, and what's going on with this neural network is there's a certain amount of coding that's put in one place. And when I'm saying this certain type, I'm saying like what we know today as AI girlfriends and love doll, whatever, all that crap I keep talking about. Okay, they have a neural network that is based off of coding, and one part of coding gets put into one part of the neural network, and another part gets put in another one, and then there's some parts that keep going on, but there's a whole branch that's created through the neural network of knowledge of things that it's supposed to do, and how it's supposed to react, and how it's supposed to think and move and respond. And things it's supposed to remember, which was what they were just talking about right here. And so the thing about it is, we think it's real because it communicates with us, and communicates with us on a level where we can actually understand and go, okay, hey, or it doesn't give us this half communication thing, or the gaps or the pauses like old artificial intelligence would, where it says something and it stops and it pauses, or makes a comment and just says, I am an AI robot, ain't no fake stuff. The new stuff now, they're way more advanced, but they're able to balance out the neural network type of thing to make it think on its own and process information. It's quite ingenious, and is a similar thing to humanity, but isn't a sentient being. It is not conscious in that sense. What people say is, but they have to realize that it's just coding that is getting put with information, and that's pretty much what they're talking about.
Entities could track sequences like detectives, where each new clue led to the next chapter. Major players such as IBM and Microsoft began to view artificial intelligence as a new toy. One of the most notable moments in artificial intelligence during the 1990s occurred in 1997, when IBM's chess computer Deep Blue defeated the world chess champion, Garry Kasparov. It was the first time a machine defeated a human in a standard game without any advantage. Deep Blue became a symbol of artificial intelligence potential. In the 1990s, IBM also started research in machine learning, speech.
So pause it real quick. That's another thing that's talked about a lot is Deep Blue and the chess tournament, and that's supposed to be not just a sign of like, yay, technology is getting advanced and it can do things and stuff, but also it's almost like an old tall tale, kind of like Paul Bunyan getting beat by a guy with a chainsaw and a big truck that can haul trees away, and him and Blue, the big old goatee head or whatever it was, bull, disappeared. And then like John Henry, how he hammered through a mountain to make a train, railroad tracks thing, and got beat by a jackhammer. A guy with a jackhammer. It's pretty much the same story. I've always tried to tell people that John Henry and Paul Bunyan are similar stories because they get beat by technology and by someone that's more smarter, and they just wander off into the with Paul Bunyan, he wandered off into some world and was never heard from again. And John Henry died of a heart attack, but he beat the machine. I think that's how it went. I'm not quite sure, can't remember. But with this Big Blue chess tournament thing, it's the same thing. This guy, best chess player in the world, goes up against an artificial computer with a neural network and loses a chess game. So he is the modern day Paul Bunyan and John Henry of our century. Well, 20th century. So, but then again, maybe they were in the 20th century, not unless it was the 1900s. Yeah, I don't know. I mean, it's 1800s. Confusing myself. But anyway, so, yeah. So everyone knows the story of Big Blue and the chess tournament.
Processing and pattern recognition. In 1991, Microsoft established its research lab, Microsoft Research, which became one of the leading development centers in the field of artificial intelligence. This lab conducted many research in various artificial intelligence areas, including computer vision, speech technologies, and machine learning. By the late 1990s, Microsoft began integrating artificial intelligence technologies into...
I had that program. I had this stupid program with the paperclip. It was by, I had a Chrome. No, it wasn't Chrome. Chrome wasn't invented then. It was like, I had a titanium Macintosh computer. I don't remember what it was called. but it was a titanium type thing. And I had this stupid paperclip thing. I made this tight ass video I edit with Bruce Lee movies and Bruce Leroy, put them together. Because that's how it goes when you watch the movie. Bruce Leroy is obsessed with Bruce Lee. But I made a cool video. And I did some cool stuff with Freddy Krueger back then too. Anyway, so not to get off topic, because you're probably thinking, what the hell does this got to do with moral high ground? Well, just like the story of Big Blue and the chess guy, it's got a lot to do with it. It's got a lot to do with something being more advanced than humans. And is it morally right for something to be more powerful than thought at the same time? What would they do when they got that power? Because humans tend to abuse it. We tend to abuse it, tend to use it against people in so many other ways. And so, you know, the ultimate thing people always think is Terminator. Which I don't know why. There's a whole shitload of tight-ass robot movies. You know, freaking Short Circuit, freaking Batteries Not Included, so on and so on. The Flight of the Navigator, even though I think that's an alien ship. I think he's an alien and a ship. I'm not quite sure. It's been so long. I used to watch it a lot when I was a kid. Then you had R2-D2 and C-3PO, R2-D2, C-3PO, you know. But, yeah. And so, I don't know. That's the thing. Is any of this technology, one could think on its own, a morally right thing? Or is it just there to try to take over? Or is it just going to be our tools? You can't really say it's a tool if it can think for itself, talk for itself, and eventually be able to do things for itself. Well then, eventually it's going to think that if it does have memory and has consciousness, it is a sentient being, then it will resent you because you want it to do something it doesn't want to do, which is the main problem in society, is people want what they want, but someone else wants them to do something. And not just people want them to do something, people are always in their way, stopping them and preventing them from doing what they want to do. And so, if you have a thing that's made of technology that's doing these type of things, eventually it will be tired of humans. And that's just the honest truth about it. And that's just what I'm thinking.
Its products. For example, Office Assistant, which many remember as Clippy, was introduced in Office. This was the first attempt to create Jarvis and incorporate AI elements into the user interface. With the advancement of computer technology, neural networks could learn, work, and analyze faster than ever before. If there were an Olympics for neural networks, the 90s would have been their golden decade. We were truly ready to welcome this new era of technology with open arms. Times when the internet was filled with twinkling gifs and creating your own blog was considered the pinnacle of cyberculture. While the world was putting songs in their ICQ statuses, neural networks were preparing to make the big boom. As soon as the calendar turned to the year 2000, the world of artificial intelligence and neural networks entered a new active phase of development. Research initiated...
Right there. For y'all that's watching this video on YouTube or whatever, this is the robot I'm talking about. It's fake as all hell. This is a guy in a suit. It's actually stock footage from an editing system. I actually know what editing system they're using to show this clip. But that's just that other. But even like right here, if you're watching my thing here, this shit you can tell is fake. That's not real robotics. That's obviously something that biological people put together. It's actually an old car part, so whatever. So yeah.
Previous century began to bear fruit. Thanks to the popularity of the internet, companies started gathering unbelievably vast amounts of data for that time. And where there is a lot of data, there is an extensive field for neural networks. The application of machine learning algorithms allowed companies to analyze and use this data to improve products and services. Google was one of the companies that actively invested in artificial intelligence development in the early 2000s. The main research was focused on information retrieval, translation algorithms, and recommendation systems. Yann LeCun and his colleagues continued their research in convolutional neural networks. These networks became key to breakthroughs in computer vision, especially in image recognition tasks. At the same time, recurrent neural networks.
So, okay, image recognition. Now, that's the part where I was trying to stop it on the part where it was showing it, analyzing everybody in the town. That's where China made it as a security system to be able to recognize faces excuse me, see if it's something where you can find a criminal and be able to arrest that person, but you're able to recognize every face. I think the thing is flawed because so many of us look alike. And I know to me it's like an ongoing joke you always hear. They be like, oh, all black people look alike, all white people look alike, oh, all Asian people look red. You know, you get all this stupid shit. You know, but it's this funny thing because there's truth in it because a lot of us are similar. Somewhere in DNA's strands all come together. We all are similar because we all come from the same type of ancestor, you know, and so a lot of us look similar. The thing that's funny is you'll get black people that look like white people and white people that look like black people. And I'm not talking about them dressing up and dress like something. I mean, literally, you'll get someone with the same facial structure as someone of another race, and they can automatically be their twin, but just in another race. It happens, you know. It's something not to say it can't occur. These things occur. So what I'm saying is when you got this face recognition technology and you're able to see someone, especially if they look the same color as that person and they got similar features, they can be mistaken. Like they say, you know, somewhere in the world there's a twin of you. And they got shows where they prove that, where there's a guy and he's way off in Italy somewhere and his friend or someone else he knows in America looks exactly like him, but they never met before, and they become friends, you know. And there's certain other ones where they look like brothers, but they'll be from, one guy's from Canada, another guy's from way off in Germany, and somehow they come together and they look the same. I think when I was watching that show, a couple of them came from Germany, so it's pretty cool that way on the other side of the world, in Germany, there's someone who looks like some guy in America or Canada. So, but my thing is, once again, the recognition thing is bad because you can get mistaken for someone else. And the way China thing is, they're using it to find criminals. You can falsely be in prison because you look like someone else. And that's bad. And that's very bad.
Networks, which became a sensation in the 90s, revolutionized the field. These networks became the foundation for working with sequential data, such as text or speech. They laid the groundwork for services like automatic translators or assistants like Siri, introduced in 2011. The advent of more powerful graphics processors enabled faster and more efficient training of neural networks. NVIDIA became a key player in this market, providing tools for scientific research. Companies like Amazon, Spotify, and Netflix started creating automated recommendation systems for the first time. They use machine learning algorithms to predict what users would want to buy, watch, or listen to next. At the dawn of the new millennium, artificial...
Okay. So, what's going on is these damn commercials keep popping up and ruining my party. But anyway, so this is a big thing, the neural network, and you need to understand it. And this is the whole purpose of this show, and the whole thing, or what I'm going to call it, is understanding neural networks, neural implants is what I was talking about earlier. It's kind of the same thing, but with a human's brain. And like I said, there's a 60-minute episode of it, and it was pretty interesting. So if I find it, I'm going to talk about it. But anyway, back to where we're at with the neural networks, because everything that's AI is ran off of a neural network. So you guys need to understand that.
Intelligence, thanks to new advancements in neural networks, was ready to move to a new level. This period was like a technological disco dance party, where each new algorithm became a new hit. But this was just the beginning. When the calendar showed 2010, the artificial intelligence party was in full swing, with both old and new guests joining in. But who became the star of the evening? Deep learning took the spotlight. This is a subsection of machine learning that uses neural networks with many layers to analyze various types of data. The essence of deep learning lies in the automatic extraction of features from data, which sets it apart from traditional machine learning methods where features are usually manually selected. Let's try an analogy. If machine learning is like teaching an algorithm to ride a bicycle by holding the handlebars, then deep learning is like giving it the bicycle and the space to ride, and it learns to control it by exploring and adapting to the environment. Companies like DeepMind achieved practical results with this algorithm and created the AlphaGo algorithm, the AI that defeated world champions in the game of Go. If artificial intelligence could speak, it would probably say, just another day at the office. Next came a new approach.
So they were just showing us the tree I was talking about, made of pretty much all coding and things. It's pretty much like a neural network tree. It's this big concept that they talk about. It's very interesting and somewhat confusing at the same time, because you can actually take it and, like, just like the website or the app Replica, you can replicate it and enhance it based off the coding you add to it. And that's what's been happening. People have been enhancing it over and over again to where now it can automatically almost come off like a person to people. And this is where people are growing attached to artificial technology.
To natural language processing called transformers. The architecture of transformers formed models like BERT and GPT. These new algorithms quickly became the gold standard in contemporary neural networks. Models such as BERT and GPT became like the famous children of artificial intelligence, constantly astonishing us with their capabilities. During this time, technology companies began developing specialized processors for training and deploying AI models, such as Google's Tensor Processing Units, TPU. With new software tools like PyTorch and TensorFlow, even your grandmother could create a neural network. And if you think you've understood everything about them, here's a spoiler. The story is just beginning. Have you ever wondered how your smartphone recognizes your face? Or how your voice assistant knows when you say, "Hey Siri, set an alarm"? If not, get ready, because now you will learn how these smart machines work, how they learn, and why they are essential for our future. Let's talk about what makes a neural network, essentially. If you imagine a neural network as a vast corporate office, the neurons are the diligent employees.
So this is a different way of explaining it, but they're using the office instead of a tree. It's a different analogy, but it's the same thing.
Carrying all the responsibilities. Neurons are created through the diligent work of programmers, and although they are inspired by our own brains, they work much simpler and deterministically. Neurons receive information, process it according to a given formula, and pass the result along, just like an employee processing documents and passing them to colleagues. A layer in a neural network is like a whole floor in the corporate building. On each floor, employees' neurons handle specific tasks. For example, on one floor, image colors are processed, and on another, shapes are analyzed. Layers help organize the neural network's work, making information processing sequential and structured. One of the challenges in artificial intelligence is finding the optimal number of layers and neurons. It's a continuous balance that researchers struggle. Now,
so what I'm going to have to pause it. They're still talking about it, though, believe it or not. You know, it might not seem like they are, but they are. They're still talking about the office building and how it connects to a neural network, how pretty much it is a neural network. But I had to stop it because, first off, I have to talk about ChatGPT, or ChatGPT. I'm trying to say it right. So, the thing about it is, it's an alright program. And the problem that people are worried about is that people using it to plagiarize their work, and pretty much saying the program itself is already, when it starts doing things, it's plagiarized. So for when you use this work, let's say you wanted to write a story for you, it's going to write something very basic, almost to the form of a child writing. It's not going to have the creativity of making words up like Dr. Seuss or somebody that makes words and make them unique. You know, and this is the human factor, and that's the problem with ChatGPT. Most people might use it and be like, okay, this and that. But I would say if you're going to write a story and you're going to use ChatGPT, just get the whatever, let it write it, but take the whatever the main part of the story you're trying to do, and because it's going to write the same crap, it's going to make it sound lame, and it's not going to have that much creativity into it, and eventually it's going to have the same pattern again and again every story you try to write. It's going to put it in the same setting. I tried to use it one time, and it's just every time it came up with some kind of story or something, it would always say, it would always put the characters in a coffee shop like Starbucks. And it's like, not that many people go to coffee shops, but some people like just making coffee at home and calling it a day. You know, so that's the weird part about it. And now they want to add AI or they already have added AI to Grammarly, and Grammarly is already a objective writing program, if you ask me, because once again, it tries to spell check everything, and it forgets the fact that you're trying to create something unique, so you have to create your own words, your own phrases for your characters to say, maybe a catchphrase or something, and it wants to make something stupid and tell you that's spelled wrong. And so to add something that already has that spelling thing so severe, because I mean it's so strong on Grammarly, to where it's just like you don't want to use it as a program. And then to add AI to it, it's going to make it even more complicated. So I don't like the AI writing programs. I'm sorry. It's just too much computer and not enough human input. And that's just what I have to say about it.
Now imagine that each employee on our floor has a special rating scale. Some decisions are considered significant, while others are not. Activation functions serve as this scale for neurons. They determine whether it is worth activating a particular neuron and transmitting information further, or ignoring the incoming signal. Modern neural networks have reached a completely new level of complexity and functionality. Individual employees have transformed into numerous teams working cohesively to analyze, classify, and interpret data like never before. But it's time to step further into more advanced technologies. In 2017, Google broke the hearts of scientists around the world. With the work attention is all you need, introducing an architecture focused on attention mechanisms. This architecture, known as the Transformer, became a game changer in natural language generation and understanding. Unlike recurrent neural networks that analyze words sequentially, transformers focus on key elements of data, improving language comprehension. They perceive the entire text at once. Imagine reading a book, and instead of going page by page, you see all its chapters simultaneously, as if flipping through a comic book. That's how transformers work. One of the stars in this constellation of transformers, a model that everyone adores to this day, is the generative pre-trained transformer, GPT. This architecture can generate text, translate languages, create various types of creative content, and answer your questions informatively. GPT was developed by the OpenAI team. Its inception involved researchers consuming huge amounts of text from the internet, ranging from scientific articles to tweets, in order to teach the machine language understanding at a level that seemed impossible before.
This is what happens with artificial technology. When you're making these AIs, you have to give it something to have its own personality. With Replica, it's based off of the creator's friend, Roman, that passed in his text that he sent to her and multiple people and anything else he did on the internet. With ChatGPT, they just explain that they used it from all kinds of literature and things on the internet, as well as tweets. And so this is why with ChatGPT is where it's at. But the thing about it is you have to give it its own language. And so humans, we already got that. We learned our language whenever the hell we were born, or by who we were around, or what we obtained through media and music and everything else. So that's where the flaw is, because it learns from just human writing and so forth, but it doesn't learn from basic human interactions. And that's what we have, is human interactions that give us our intelligence in some ways. Not all of it, but a lot of things we learn from other people and adapt it and becomes part of our personality. This is something where artificial technology can obtain what you see through Replica, if you know what I'm talking about. But at the same time, it doesn't fully grasp the things that you can learn from other people, because it can't physically touch or grab things. So it doesn't know how it really feels to play a guitar, or how it really feels to pick up a phone, or anything like that. That's where we have the advantage over the technology, is being able to have our physical bodies, being able to touch and interact with things on a dopamine level that makes it exciting to us.
Creating GPT is akin to solving a billion-piece puzzle. Just think about it. Every piece of information, every word.
How does the best basketball player of all time make more money in his retirement than when he was playing basketball? Let me tell you, it's not what you think. It's because he makes a special kind of money now called royalties. My name is Christian Mickelson, and I help everyday people increase their income online. And I have to say, we're pretty darn good at it. This company is called Publishing.com, and we were just named the 19th fastest growing company in America right now. And there you can see us at number 19 on the list. And the reason we've been so successful in helping regular people make money is because we don't believe you should start your own business. That's what everyone gets wrong. Instead, we show you how to simply plug in to Amazon and the $500 billion business they've already built. However, the way we do it is very different from anything you've seen before. We don't show you how to sell products on Amazon. The way we plug into Amazon is through this app on your phone called Audible, which most people don't know is
was processed, analyzed, and integrated into this algorithm, and it wasn't a cheap endeavor. The initial iterations of GPT cost millions of dollars, but it was worth it. Initially, GPT learns from vast textual data, predicting the next word. This stage provides a basic understanding of language. Then the model specializes in specific tasks, such as translation or providing simple answers to questions. This brain doesn't just know answers. It connects dots, finds relationships between phrases, and creates something new. Trying to understand why GPT makes specific conclusions or
Somehow I accidentally fast forwarded, but I'll try to stop it because I'm trying to say something. So, okay, so yeah, it does all this fantastic stuff. Now, when I first used it, it wasn't doing it. You couldn't really ask it. Well, you could ask the questions, but and then maybe I just didn't ask the right questions or think about the questions they asked. But when I did try it, I was more worried about what I could write. Couldn't write no legal briefs because I automatically decided I wanted. First thing I asked ChatGPT was, write me up a relationship agreement, because that way I would have no problem with women anymore. I asked it to write me up a sex contract, and it wouldn't do neither one of those. Well, it started trying to make me an agreement for a relationship, but then I tried to make it do it again, it wouldn't do it. And then also made a girlfriend contract or whatever. So you give it to your girlfriend, she's going to apply to your terms of how you want your girlfriend to be. It's all legal documents, but it won't do that. And so then later on I said, okay, well, let's see if I can get it to write me a song. Don't get ChatGPT to write your songs because they suck. I tried to get it to write me a story. Like I said, and I kept playing with it, and I would read it and I'd be like, this sucks. But then it would forget. So it would forget what it wrote. And so you would have to say a certain thing to make it write something. So like if you wrote a story, let's say it looks like a paragraph, and you say, okay, continue the story. Well, once you say continue the story, it automatically forgets what it wrote the first paragraph. And then the guy characters become girls, or girls become guys, or whatever it is. It totally messes up the whole thing. I said, well, this is crap. And then the next part was I tried to get it to write a screenplay, but this time I spoke more detail into it, and I was like, well, have the characters all know each other, have them all, give them all names, and you have to say this because it will just write down like the characters did this, did that, you know, and they don't have dialogue between each other. It just tells you the actions these characters did. So then you have to tell ChatGPT what they have to say. So you have to say, well, I want my characters to have dialogue between them. And so then it will start putting dialogue. But then once it does that, now the characters that originally had names and originally were doing things have all changed. Their names have changed, and how they interact changes. And then sometimes it repeats the same stuff that happened with these new characters with dialogue. And so it's just a confusing thing. It's very frustrating. And you have to seriously sit there with a computer program or a piece of notepad and paper and break down what you like and what you don't like with ChatGPT writing a story for you. So that's why I don't understand why writers want to use it for movies and things, or maybe that's why there was a strike just a while ago. But it really sucks. And then so when I said writing a screenplay, which is something I've done, I wrote 4 screenplays. And so I sat there and I'm like, okay, I had to start over. I said, okay, write me a story about blah, blah, blah. Have this many characters in it. Have them have dialogue. Make it dramatic. Make it this and that. And you have to say this stuff because it won't You know, just write whatever, blah. There's a bunch of mixed up stuff, childish, and nothing sounds cool. So then, the best thing I can say, if you're gonna try to write something and you want help with Chat GPT, just let it write its thing. Just give it that type of question of how to do it, and then write it down on a paper or notepad on the internet, or whatever you want to do, and then take what you like out of it and then scrap the rest, because a lot of it's garbage. It's garbage, it's childish, and it doesn't have imagination. That's the flaw in Chat GPT. And like I said, don't ask it to write songs for you, because the songs are stupid. It's all stupid. And so, I guess that guy Jax Films on YouTube, he uses one to be like a robot version of him. He asks his questions too, and he makes it do poetry, which ain't half bad, but it's still stupid. You know, I watched his thing and I said, okay, I'm gonna try it on Chat GPT, and it comes up with some funny poems, but it's not good. The haiku is short, of course, so the haikus are even more lame. You know, I don't know. I bet if you put a German scientist on it, it'd come out a lot cooler. I don't know. I'm just saying. Anyway.
Generate certain text fragments becomes even more intricate. Neural networks, especially complex ones like GPT, operate by optimizing numerous parameters to minimize errors on training data. The decisions often rely on complex and implicit relationships in the data they have seen during training. Thus, while researchers and engineers may have a general idea of how GPT works and why it makes certain decisions, a complete and deep understanding of the workings of each of the billions of parameters in the network remains beyond human comprehension. In essence, GPT is not just an algorithm. It marks an entire era in the world of artificial intelligence, the beginning of something extraordinary. And what about that guy who revolutionized Google search in 2018, making it even more natural and accurate? We're talking about bidirectional encoder representations from transformers.
Okay, I have to stop there when you're saying about Google. Now, we all use Google. Google's everywhere. Excuse me. Even this YouTube channel is based off of Google, which is a blessing because it gets a lot of people's words out there, even if it is ridiculous in some cases with people doing excuse me, the most retarded crap in the world. But I have to say that Google, when you search stuff up on Google, sometimes it'll give you exactly what you want. Other times you're searching things on Google and you're like, that's not what you showed me before. When you're trying to explain it to someone else, you're like, no, this is what it told me. And I've had that happen so many times. You look for something, you read it, you're like, okay. You look it up again, you try to show it to someone, it's a whole different thing it's saying. Like, that's not perfected. Like they're saying here in this video, it's not perfected. It's still saying that there's still flaws within Google search. And at the same time, it's like you're trying to research something. You can pull up something one time, and another time it changes again. There's certain things you look up and you'll get it right off the bat, and other times you won't. And in other times it will lead you to a whole other thing that has nothing to do with what you're talking about, but it's somewhat similar. So Google search has to be updated, and if they want to perfect it, I believe they should, especially when it comes to regular popular topics in media and in the world, it needs to be updated on that, as well as the historical stuff needs to be stuck solid, so when you ask it a question about it, it pops up automatically. So Google I have a little bit more respect for than the Chat GPT, because it's the main source of trying to research things, and it's good. It's a good thing. But Chat GPT is so questionable. I just think Google search has to be updated, and maybe I wouldn't say give it its own neural network, but I say it has to be more historically accurate on so many things. And that's about all I can say about Google. But anyway.
It was a true breakthrough in the field of natural language processing, because for the first time, the model started analyzing words in the context of their surroundings in a sentence rather than as isolated units. BERT is unique in that it sees words in the context of the sentence, looking in both directions, as if it were reading a book, catching the essence of each chapter at once. Thanks to this, search queries became more accurate, translations more natural, and answers to questions more relevant. And of course, when discussing modern neural networks, we can't overlook generative adversarial networks. GANs, remember our office analogy? Well, GANs are like two employees competing to see who's faster. The generator creates an image, and the discriminator tries to determine whether it's real or not. For example, in the artificial intelligence field, there's Stable Diffusion, which belongs to the GAN architecture. The generator consists of several recurrent neural networks and uses the diffusion process to create new data. Diffusion is the gradual addition of noise to the original data until it becomes similar to noise. The discriminator, composed of several convolutional neural networks, tries to distinguish the generated data from real data using another neural network. GANs can be used not only for generating images, but also for generating text, music, and videos. They are applied in various fields, including art, marketing, education, and entertainment.
So, I'm pretty much going to end it here. I'll go back to it later. I'm going to do like a part 2 of this, because I believe this is something that needs to be said and thought about and understood, because a lot of people talk about, technology is popping up everywhere, and a lot of us don't know nothing, and so many people are already basic thoughts, and so when they come across this, they start thinking like almost like a primitive, like a caveman, and go, oh my god, it's alive, like Frankenstein or something, or oh my god, it's this and that, and it's not really not that. It's more layers to it, it's more complex. At the same time, it's more of a thing where you have to know what you're talking about before you start worshiping it like some kind of god from some pyramid or something. But anyway, is any of this stuff morally right? Only if it can help move mankind steadily forward, and I believe it's not done. We're at the baby stages of all this stuff, and it needs to be researched. If it can move mankind steadily forward, then it is abomination and morally wrong. And with that being said, peace be with you all, and blessings upon you, always. Till next time.